Hi, everybody. Uh, Hello. Glad to see you out there. This is the Science 20F Chemistry Review today. Science 20F Chemistry Review. So we are done the chemistry unit, and I want to just do a quick, brief sort of review of some of the concepts we've covered, and then we'll start the next unit tomorrow. Some of you have already probably started started watching the introduction to ecology video, so that's really great. I hope that that's happening. There'll be quite a few videos for ecology. We've done a lot of different little bits and pieces of the ecology unit. I posted the booklet today, so you can check that out and start reading. It's pretty much a completed booklet. There's not too much to be added to it. So we're going to be kind of reading through it, getting some ideas. I'm going to try to go for sort of like half classes, like sort of 30 minutes of me talking about a concept and then a 30 minutes for a video or an assignment or something, so that you can still have your hour of class but maybe not have to listen to me chatter for the whole time. But today we're going to be doing a little bit of review of the chemistry unit from our science course that we just finished. So we have quite a few little concepts to cover, and we'll do them as we go. So I guess one of the very first things we covered in this unit was the Bohr model and atoms, the model of the atom. Let's start with that model of the atom. So this is the idea that the atom is made of several components. We have protons, and neutrons, and electrons. Protons are positive, neutrons are neutral, no charge, and electrons are negative, charge, let's go charge. And then mass, we can say that protons and neutrons have mass. Uh, almost no mass. And then we also have location, nucleus, and shells, electron shells, or orbitals. So that's the idea that we want to have in our mind. This is the type of atom we want to be able to talk about. An atom made of protons and neutrons and electrons. The protons and neutrons are on the inside of the atom. The electrons are on the outside, so that if two atoms are coming close to each other, what is the part that's interacting? It's the electrons. From that point, we started discussing a Bohr model, and this is what I really want you to take away. Bohr model of the atom. And so this Bohr model has the protons and electrons in the center. So protons and neutrons in center, and electrons in shells, 2, 8, 8, what's the next one? 14, I think. 14, something like that. 14? Does that sound right? I don't know. We didn't go that many shells out. Okay. 14 doesn't sound right to me. Okay. So I'm thinking about 10, 18. It must be 18. 18. I think it's like 18, 18, 32 or something. Okay. So let's draw out, let's go like lithium. We have 3 protons, 4 neutrons, and then we have a shell. The first shell has 1, 2 electrons. The third shell has 1 more electron. Remember that the number of electrons equals protons in atoms. And the mass equals protons plus neutrons. So these are all things that we covered in a previous time. If you have any questions, please don't be afraid to drop them in the chat. This is just a review class, so it's a really good time to get some conversation going. So if you'd like to put a message in there, just drop it in the chat, and I will respond to you. Okay. If we wanted to do something a little bit bigger, so let's say we wanted to say magnesium, maybe. Think about magnesium here. Where's my? Huh. Just gonna pull up my periodic table. Well, I don't know where anything's gone anymore these days. Okay. Periodic tables. Oh, that's what it's called. Okay. No, thank you. Okay, so yeah, let's do magnesium. So magnesium has 12 protons, 12 protons, and 12 neutrons. And so we would have 1 and 2, and then we would have 1, 3, 4, 5, 6, 7, 8. So that's 10. And then we're going to have, so we have 10 electrons so far. So then we put 11 and 12. So that's our magnesium Bohr model. Okay. One other thing that we did was the Lewis dot model. And so for the Lewis dot, we are representing only the valence electrons. So for lithium, we would just go lithium dot. It's only got 1 valence electron. For magnesium, we would just put 2 dots. If we're going to do oxygen, then we would have 6 dots because it has 6 valence electrons. And this also informed us about the combining power, how many different bonds these each could make, and how they could combine with other elements. So for example, lithium and a fluorine has 1 electron here. Lithium has 1 electron. So we can think about this as forming a one bond in lithium fluoride. If we take our magnesium and our oxygen, now that we've sort of, done a little bit of this work here, we can take the idea that oxygen also has 1, 2, 3, 4, So lithium and magnesium and oxygen also can be bonded together. They both have 2 free electrons, 1 and 2 and 1 and 2. So that makes magnesium oxide, MgO. We later on did this by a different method, which was finding their oxidation states or their charge states, the ion states, and figured it out that way. But it was actually there the whole time. Uh, we didn't look at it too closely. Okay. From that point, we started doing some work in naming. So in naming. So we had ionic compounds. So ionic compounds, these are ones made of a metal plus a non-metal. So for example, if we did lithium and we went lithium oxide like this would be known as lithium oxide. If we went SrO like so, then we would call this strontium oxide. If I asked you about iron 3 oxide, iron 3 oxide, then you should know that you need to put an iron down, give it a 3+ charge, put an oxygen down, know that it has a 2-, and then do your crisscross, boom, boom, to find that it should be Fe2O3. Can erase things a little bit and clean it up. If anybody's out there and watching, please feel free to throw a comment in the chat so that I can see you and know who's watching. Right now, I just know that there's 4 of you out there watching, and if you have any questions, that's what these live chats are for. They are especially for the idea that you can send me questions while we're talking, while I'm talking. It's pretty boring over here to just kind of talk into the space and not have any questions to be answered. Okay, if we want to name some other things, let's name one more thing. What if we had? Well, there's a manganese 5 chloride. Leave that on. Okay. Manganese 4 chloride. Don't scroll. Oh, I see. Yeah, if you can always come back and pause, of course, and catch up later. Yeah, no problem. Thanks, Jacob. So manganese 5 chloride. Here we would have, this is one that we don't even have on our periodic table, but we can take the manganese, and we know what chloride is, Cl. And so there's a minus, and there's a 5+. So we can do a little crossing, and we can get an MnCl5. And then we just do a little cleanup after. Oops, don't want to clean that up. There we go. So these are the kind of skills that I'm hoping that you have for naming ionic compounds and writing ionic compounds. These can be tricky. So now we're going to move into the covalent compounds. So we also did covalent compounds. Let me just change pen, something I haven't used in a while. Okay. So covalent compounds. And those are going to be non-metal plus non-metal. So when we combine two nonmetals, we get a covalent bond. And so let's do some covalent compounds right now. This is the hard part, is thinking them up. Let's try. I'm out of ideas here. Let me say some or let's go covalent compound. Right. So for example, I and Br is a compound. So in this case, we have an iodine and a bromine together. So the first word stays the same, iodine. And then the second word has to get a prefix. There's only one of them. So we are talking about mono, bro, and then it always ends in IDE if it's just a single element. Monobromide. By the same token, we can reverse the process. Let's take something like carbon dioxide and break that down. So we know that there's going to be a carbon here, and then the dioxide suggests that there is two oxygens. If we have more than one of the first element, like in disulfur, dichloride, then we would write S2Cl2. So Cl2O7 is going to have also two prefixes, dichlorine. Notice that the first word is not modified. In the end, it only gains a prefix. And now there are 7 oxygens, so that's going to be heptoxide. Oops, too many letters there. Oxide. Okay. So this is one of the things that we did. And so now we're going to move on to balancing chemical reactions. So the next step was, now that we were able to name them, we started to make chemical reactions and balance those chemical reactions. Be careful. So I think we just saw 4 at the point. So let's write out a chemical reaction here. Let's do something like where did my screen go? Okay, so let's do something like let's do all the examples of chemical reactions. So the first one we have is a single replacement. So a single replacement is where we have an element like iron, and we are going to add it to something else. So Al2O3. And the iron and the metal oxide or the element and whatever compound are going to switch a partnership. So iron and aluminum oxide, we're going to get iron oxide, iron 2O3, plus aluminum metal. And that's that single replacement. And then we look for a balance. We double check. We have only one aluminum here. And we have 2 aluminums over here, so I'm going to put a 2 in front. And then I have 3 oxygens and 3 oxygens, so that's good. And then I'm going to check my iron, and my iron, I have 2 irons, so I'm going to add a 2 in front. Let's do one other single replacement. So maybe let's take some iodine, I2, and add that to some, or no, let's do chlorine, add that to some potassium iodide, and the result's going to be some potassium chloride plus I2. So we have a pure element on the left, chlorine, and a pure element on the right, iodine. And they are swapping partnership with the potassium. So I'm going to start my balancing on one of the ends. It doesn't really matter where I start. I'm going to start with the iodine. I'm going to compare iodines on both sides. I see I have I2 on one, so I'm going to put a 2 in front on the other side. I now have made 2 potassiums, so I need to double that number of potassiums. And then I check with my chlorine, and I see that that's fine. So I don't have to worry about that one. And that's the sort of balancing we were doing in the previous week. So that's our single replacement. So let's move to the double replacement. So in a double replacement reaction, we have 2 reactants, and they are both going to switch partners. So it's always the hardest part is just thinking about all the different examples. So let's make sodium fluoride and beryllium chloride, something like that. So that's going to make sodium chloride and beryllium fluoride. We're going to get searching here. We're going to start with anything. It doesn't really matter. I don't know why I'm starting on the right. I keep starting on the far right. So I'll start on a different spot today. I'm going to start with, I start with something that's different. So I'm going to start with chlorine here. So I compare the 2 chlorines. I have 2 chlorines on the left, 1 chlorine on the right. So I'm going to put a 2. Now I'm going to compare the sodiums. So I'm always going to go and follow through. So there are 2 sodiums and 1 sodium. So I'm going to put a big 2 in front of that sodium fluoride. Going to compare the fluorines now. There's 2 fluorines and 2 fluorines, so I'm done. Make another double replacement. I'll try to make a hard one here. Let's try something like with magnesium. Let's go magnesium oxide plus aluminum nitrate, maybe. Yeah, that'll be hard to do. Okay. All right, so that's the trickiest one I can imagine. Oh, no, that's not quite right, is it? No, that would not be. Okay. Let's do sulfate, aluminum sulfate. Okay. Something like that. And the result is going to be aluminum oxide plus magnesium sulfate. That wasn't tricky. I don't think this is going to be as tricky to balance as I hoped it would be. Oh well, that's okay. So we are going to just start with any inequality we want for balancing. So let's start by comparing oxygen. So oxygen's not equal. So let's fix that. We're going to put a 3 in front. I'm going to compare my aluminums. My aluminums are good. I'm going to compare my sulfur. My sulfur is not good. So I'm going to fix it. And now I'm going to go back and compare my magnesium, and I'm good. So that's the final answer there. I wouldn't mind going back and erasing all these arrows. I find them very distracting. I think that if I was marking this, it could be a little bit distracting to see them all, but I think they lead the point. They do show your work at least. Okay, double displacement. So the next one we would have done is maybe a synthesis reaction. So this is when two things come together to form one. Classic example is rocket fuel. And again, let's do some balancing. We've got an inequality here in the oxygen. There's 2 oxygens and 1 oxygen, so let's multiply by 2. This gives us 4, so let's multiply by 2, and then we're balanced. And let's try something else. Let's try, another synthesis, eh? Okay, let's try carbon plus oxygen to make CO2. So that would be, burning graphite or synthesis of graphite. And so in this case, we have a balanced reaction, right? We can do the balance if we want. We compare. We say that's good. Follow the carbon around. We say that's good. So it's all balanced. So even if we have a case where the reaction is already balanced, this little arrow method does work. Okay. Decomposition reactions was the fourth type. So now we're going to start with something and we're going to have it fall apart. So let me think about something I want to break. Let me try. Feel like having some other combination. Oh, okay. Let's try H2O2. So H2O2 produces water plus oxygen. So let's do a little balancing. We see that the hydrogens are balanced. So that's boring. So let's not start there. But we do on this side, we have an imbalance in oxygen, right? So here we have 3 oxygens and we have 2 oxygens. This is probably the hardest one we've done yet because we are seeing the oxygens are split between the two products. So what are we going to do to balance that? Well, if we we could double this, and that makes it 4 oxygens, but the balance is still not there for the oxygen. So we always want to fix an inequality first before we move to the next element. So we've got 4 oxygens, so let's put a 2 in front of here. That gives us 4 oxygens. And now let's go and check the next element. Next element is hydrogen, and there's 4 of them. The oxygens and the hydrogens are fixed, so we are balanced. I'm going to just do a little bit of shrinking here because I'm losing space. So let's get one more decomposition reaction in here, and then we'll go to combustion and the newest reaction, which is the neutralization reaction. Another decomposition. Let me think. How about... No, that one looks too tough. Calcium carbonate's not a bad example. Yeah, it's pretty similar. sort of boring. Boring, boring. I'm looking at a list of them. Oh yeah, okay, that looks at least a little bit interesting. Let's do potassium chlorate, which decomposes into potassium chloride plus oxygen gas. So I'm going to look for an inequality. So far, the potassium and the chlorines are balanced. So my inequality that I want to study is my oxygen first. How am I going to fix this one? I've got some problems here. There are 3 oxygens on the left and 2 on the right. So the only way is to sort of, almost crisscrossing, right? We're going to multiply one side by 2 and one side by 3 because we had subscripts of 3 and 2. Now they've been multiplied, I have 6 oxygens on the left and 6 oxygens on the right. And now I can look for my other balancing point. Let's take the potassium, for example. I look and I see that there's 2 on the left and 1 on the right, so let's put a 2. And now we are good to go. Okay, last 2 reactions. We have the reaction that we call the combustion reaction. Which produces CO2 and water. There are in chemistry we have more types of combustion reactions. We might call a lot of different types of reactions combustion, but we are specifically talking about carbon products in this example. So let's take some ethane, which is C3H, 1, 2, 3, 4, 5, 6, 7, 8, and H8. So that's ethane. You might have some ethane in, well, we don't usually use ethane we should use propane really. That's something you have in your house. Let's do propane. Good idea. Okay, so C4H10 is propane. We're going to react that with some oxygen. So this is just like your barbecue. If you have a propane barbecue or even a propane, if you have a propane powered stove for camping or whatever, this is what's happening. Is you provide a little match and you combine the oxygen in the air with the propane gas, and a reaction happens, forming CO2 and water. Always the same 2 products. And then we are going to do some balancing. So let's get into that balance. Probably the easiest place to start is to balance the carbon first, or balance the hydrogen first. So let's do hydrogen first, why not? So hydrogen is 10 on this side, it's 2 on the other side, so I'm going to go with a 5. And I'm going to flip-flop my arrows so that I can think about following. I like to follow and do oxygen last. So my hydrogens are balanced. Now I'm going to take my carbon and try to balance it. So I need 4 of these. And now I'm going to do my oxygen balance. So my oxygen balance here, and I've got to split my oxygens. So I get 5 oxygens here, and I get 4 times 2, which is 8 oxygens over here. Uh-oh, this is not going to work out. So I have essentially 13 oxygens on the left, but I have a value of 2 on the right. So the only way I could balance this is if I sort of I went to twice as much or something similar. So, one of the big problems is that hydrogen. We only have 5 waters. If we had 10 waters, then we would have 10 oxygens. So I think we're going to have to fix that. So we're going to fix the oxygens first, I guess. we essentially we know that the hydrogens and carbons are already balanced. So the only way we can fix it is to double everything. So we're going to go times 2 on both sides, on this side, and then we're going to do to give us 26 oxygens, and then we're going to go times 13 to give us 13 to give us the 26 oxygens on this side. So timesing by 2 means that we're going to actually convert this to 8, and we're going to convert this to 10. Okay, now I've got to do it all over again. So I'm going to change to yet another pen, maybe green. I'm going to go, okay, 10 compared to 10. That's not good enough, right? Now I have 20 hydrogens, and I have only 10, so I got to put a 2 in front. That 2 in front means that I now have 8 carbons and 8 carbons, and I've got it. I did it. Okay. Whew. There was a little bit of like an uneven moment there in the middle, but we figured it out and we got back into it. So this is where, don't give up. Don't go back to the beginning. Just stop and just keep pushing forward. If you reach an inequality, fix the inequality, move to the next element. Even if it means you're going back to the same elements again, that's okay. So let's do another combustion reaction. Let's do, we can do a complicated one. So uh, let's try ethanol. So that's like in your, usually I think barbecue lighter is ethanol. Okay, so ethanol looks like this. Ethanol, HOH. Let me think about that. 1, 2, 3, 4, 5, 6. So it's something like that. I'm going to write it out in a little bit of a nicer format for you. Something like this. So this is ethanol. You don't need to know how to name it, but it can be useful. It can be fun to think about that this is something you might have in your house right now. If you have any spirits in your house, then the spirits like drinks in your house, then that's ethanol. Carla, thanks. Yeah, it was a bit of a wild balance. Sometimes you gotta go through twice. We just keep looping. So we still know that it's going to be CO2. We still know that it's going to be water. And yeah, this one's probably going to be tough too. So this is going to be our most extreme balancing yet. I'm going to start with carbon again, or with the hydrogens. Either or is fine. So let's start with hydrogen. That should be fine. So let's see how that goes. So we're going to put a 3 in front. I'm watching out for that 3. Every time I see an odd number now, I know that I need to worry about it. So I'm going to see that 3 and see how it goes. Again, I think I want to do the carbon first. So I'm going to do it this way so that I can go straight to the carbon. Okay, so now I have sort of my ethanol balanced with the carbon and the hydrogens. And so as long as I change these together, then I can do anything I want at that point. So let's do the oxygens now. And this is why this one's going to be a pain, because over here we have 3 oxygens. So we have to compare them together. And then over here, ooh, that's going to be fun. Okay, we have 3 oxygens and 4 oxygens, right? 4 oxygens and 3 oxygens. So together we have 7 oxygens. This might not be too bad. Could we just add oxygens from this one, this pure oxygen until we get to that balance? So for example, what if we had a 2 in front? What would that do? Sometimes I don't know exactly what the result's going to be, so I just start adding up things. 2 times 2 is 4 plus 1, that would be 5. Okay, not quite there. What about if I went with a 3? 3 times 2 is 6. 6 plus 1 is 7. And I didn't touch my ethanol at all, so my ethanol was safe. So everything else should be fine. I didn't interrupt, I didn't put anything in front of the ethanol, so actually I balanced it. So 1 ethanol plus 3 oxygens gives me 2 carbon dioxides and 3 waters. There are definitely some combustions that are easier and some that are harder to do for sure. Okay. We have one new reaction that we did in the last week or so, and that is the neutralization reaction. So we're a little bit out of order now. Neutralization reaction. This is an acid plus a base that gives us a salt and water. So these ones are usually not too rough. So let's start with our basic one, HCl plus NaOH. That's a almost on purpose joke. And so the reaction here is going to produce H2O, which is our water, and our salt. And this is the one I would like you to be able to figure out, is to be able to put your salt back together. So here we have sodium and chlorine. Check the balance. Looks good. On to the next one. Neutralizations are a weird double replacement type reaction. Or they're not weird. They are a double replacement, but with that specific result is a salt and water. Let's do a hard one. So let's do something like H2SO4, which is sulfuric acid. And we'll just use lithium hydroxide, which is a strong base. Not as strong, but it's strong. And so we're going to get water and Li2SO4. Let's do a check. The Li's are unbalanced, so let's fix that with a 2. Check the sulfates. Sulfates are balanced. So let's check our hydrogen numbers. And I notice that I have 4 hydrogens, and I only have 2 hydrogens over here. So let's put a 2 in front. That gives me 4 hydrogens. And then let's do a last minute comparison of all of the oxygens, just because we haven't done them yet. And so I've got 2 and 4, that's 6 oxygen. 4 and 2 is 6 oxygen, so I am good to go. Okay, so that's pretty much everything we've done. The only thing that I'm missing here is the pH scale with discussing acids. So we did have, that would be the last step, and then plus any of the environmental things that we discussed. So so we talked about acids. Acids produce H plus ions and are low on pH scale. The pH goes from 1 to 7, or maybe we should just say less than 7. Water is neutral, pH equals 7. And bases produce OH minus groups. OH ions and are high on pH scale. pH over 7. That's pretty much the most important aspects. Maybe there's some properties there. Acids are sour, bases are bitter. So let's maybe make a little table here. Acid and base. We've got sour, bitter, less than 7, more than 7, pH, slippery to touch. Usually acids are not slippery. Thank you for the update. And yeah, what else do we have? Is there anything else? I think, what is it? Acids and metals produce hydrogen gas. Acid, base, properties. One of the best things you can do is if you're ever looking for anything, I always just type it into Google Images. I always search through Google Images, and usually somebody has made a PowerPoint at some point. So right now, I literally typed in acid-base properties into Google, but went over to the Images tab, and I can see all of the little previews of all the images, and I can find a whole bunch of interesting facts about acids and bases because there are so many different little PowerPoints that have already been made that sort of assemble all this information, and I don't have to really I don't have to click on any links. I can just use the preview view to access these. So another thing we didn't talk about, which is conduct electricity, and this is also the case for our other one. So acids and bases both conduct electricity. They both have charged ions. And they react with acids to neutralize. They react with, I guess acids are the only ones that have a good reaction we can talk about. They react with metal to make H2 gas. So there we go. So that's probably all the properties we really need. Isn't that two gases? Are we talking about the acids and bases? Not quite sure what you mean by the question there, Scott. So maybe you can clarify. Okay. Well, I'm going to, I think that's pretty much it. That's the whole unit. So if you can give it a quick review, read through the unit again. But if you can do all of these things on the unit, um, then that would be, then that is, then that's what we're really looking for. So is all of these abilities. So I'm gonna try to produce produce a sort of online form from Google through Google Forms probably. I'm looking at some other sort of online test tools to send to you. I'm gonna try to get that to you probably by Friday so that you can try it over the weekend. Next week is spring break, so I guess I'll stop streaming for next week. Um, Although I feel like we could probably use the time to catch up, honestly. But I won't make you work through spring break. I might make some other videos in the meantime and post them, but or maybe post some topical videos to watch for our environmental unit. Otherwise, tomorrow will be the first day of our ecology unit. It's a pretty quick unit. It has a lot of ideas. But otherwise, this is the end of this unit. On Friday, I'll post a online sort of quiz test thing to finish it up, and then you'll be on your way. I think that's good for today. And so hope you're all staying safe and staying well and washing your hands, social distancing, whatever it is. And I hope to talk to you all again soon. Have yourselves a great day, and we'll see you tomorrow. Thanks for showing up.